Hello, you are most welcome. I'm Teacher Ivan from Wuuna Educational Services. We are here for our third lesson concerning density and relative density. We are still looking at density, and please, this is our third lesson. If at all you missed the previous, please, I request you to go to our playlist, look for O-level physics calculations, go to the most recent videos, watch videos of density so that you catch up with us and we move smoothly together. Today we shall be looking at the density of mixtures. Yes, mixtures are simply comprising of different substances physically combined. Suppose we have two substances, X and Y, whose masses are known as mx and my, and volumes Vx and Vy respectively. When these two are mixed, then how do we get the density of the mixture? This is how we shall come up with that. Density of mixture is given by mass of the mixture divided by the volume of the mixture. How do we get mass of the mixture? Get the sum of the masses of these individual substances. That gives us the mass of the mixture. Similarly, to get the volume of the mixture, we simply add up the volume of the individual substances that are making up the mixture. And therefore, density of a mixture is given by mass of the mixture over volume of the mixture. In this case, we are considering two mixtures, so we are considering two substances that are mixed to come up with one mixture. The substances are X and Y. Their masses are mx and my with respective volumes of Vx and Vy. That means that to get the density of this mixture, we shall have the total mass of the individual substances that are making up this mixture. That is mx plus my divided by the summation of the volumes of the individual substances, which is Vx plus Vy. And therefore, the density will be mx plus my, which is the total mass of the mixture, plus divided by Vx plus Vy, which is the total volume of the mixture. So that is the formula for getting the density of mixture. Let us look at an example. However, before we go to example, I kindly request you to please subscribe to our YouTube channels. Starting with this very one, hit the subscription bell. You also hit the notification bell so that you get notified whenever we have a new video for you. That's what you can do for us. This service for free. What you can do for us is just to subscribe. You also comment, like, and share with classmates, friends, family members, anyone that you think this information may be important to. We have various channels. You can go to our homepage, scroll down, you will see those featured channels. Please subscribe to them. We have Facebook pages and groups in the same names. We have we have TikTok account in the names of Wuuna Educational Services. We are on Twitter as Wuuna Edu Services, among other social media platforms. We have a website. Just go to Wuuna Educational Services, hit that site of the website. You go and cruise for whatever you want concerning education. We come to example. we are looking at density of mixture. In our first example, we are told that 100 cubic centimeter of fresh water of mass 100 grams is mixed with 100 cubic centimeter of seawater whose mass is 105 grams. They want us to calculate the density of the mixture. Remember, we've seen that density of mixture is given by the total mass, that is mass of, let's say, fresh water plus the mass of the seawater, in this case, over the volume of fresh water plus the volume of seawater. So that is how we shall get the density of this mixture. Now, we are given, let us summarize what we are given from the question. 100 cubic centimeter of fresh water, meaning the volume of fresh water is 100 cubic centimeter. Then we are told that of mass 100 grams, so that is the mass of fresh water, that is 100 grams, is mixed with 100 cubic centimeter of seawater. So this is now volume of seawater, which is 100 still, and the mass of seawater is given as 105 grams. So the mass of seawater is 105 grams. Now, this is the volume of fresh water. This is the corresponding mass of fresh water. This is volume of seawater. This is corresponding mass of seawater. Our task is to simply get the density of the mixture. Density of mixture is given by mass of fresh water plus mass of seawater over volume of fresh water plus volume of seawater. So we simply substitute in our formula. The mass of fresh water is 100 grams. Mass of seawater is 105 grams over the volume of fresh water is 100 cubic centimeter plus volume of seawater still 100 cubic centimeter. So when we add, we end up with 205 grams over 200 centimeters cubed. So when we divide, that is 205 divided by 200, we shall end up with the density of the mixture as 1.025. This is grams per cubic centimeter. And if at all it is required in kilograms per cubic meter, please, we saw that in our first video or our first lesson concerning density. Look for it and see how we convert. Otherwise, that is how we get density of the mixture. Let us go to our second example concerning the same. In our second example, we are told that liquid Y of volume 0.40 meters cubed and density, this time, let us read as we summarize. We are given the volume of liquid Y as 0.40 meters cubed. We are given its density, that is the density of Y, as 90.0 kilograms per meter cubed, is mixed with liquid X of volume. We have the volume of X as 0.35 meters cubed, whose density is 800. So density of X is 800 kilograms per meter cubed. So the question is asking for the density of the mixture. Now, this one is a bit different from the first, in that in the first we were given mass and volume. In this one, we are given volume and density. But don't forget that density of a mixture is equal to the mass, the summation of the masses. That would be mass of X plus mass of Y over the volume of X plus volume of Y. So here, our first target is to find the masses of the two liquids. But still, from density equals to mass over volume, don't forget that since we want mass, we make it the subject. So that gives us mass as density times volume. So that is mass. Meaning, since we are given the volumes and densities, we can find the mass. And still, we can substitute for mass in our formula. Where we have mx, we substitute m with this. Hence, the density of mixture will be, instead of writing mass mx, we shall use this. So that is rho of x, v of x. Since mass equals to rho v, plus rho of y, v of y. So we are using this instead of the mass over volume of x plus volume of y. So the density of x is given as 800 times its volume, which is 0.35, plus the density of y, which is 90.0, times its volume, which is 0.40, over the volume of x, which is 0.35, plus the volume of y, which is 0.40. So we now simplify this and we end up with the density of the mixture. So that is how we do that. The trick here was we had to first find the masses, or we could express the mass in terms of density and volume. That's what we have done. The rest is just pressing your calculator and simplify to the final answer. Otherwise, we shall pause from here for today, but we are still continuing with density of mixtures. So please don't forget to hit the bell so that you get notified when we post another lesson concerning density. I'm teacher Ivan from Wunna Educational Services. Please go to the home page of this channel. They are featured channels. Subscribe to them. We also have Facebook pages and groups in the same names. Search for them, join them, follow them, so that we make your learning convenient, simple, and easy. We have TikTok account in the names of Wunna Educational Services. We have a Twitter account in the names of Wuuna Edu Services. Join us, trust us, make us be part of your academic journey so that we work together through your academic journey. I'm teacher Ivan. See you very soon.